Okay, the 6 trigonometric functions. This, for the most part, is review from your Math 3 class. There is a little bit that's new. Okay. Okay, when we're dealing with trigonometric functions, we are dealing with right triangles. Okay, so I'm going to put theta in this corner. You can put it in a different corner, but I choose to put it here. If I put theta in that corner, what would this side be called in reference to theta? Opposite, adjacent, or hypotenuse? Opposite. Opposite. What would this side be called? Now, isn't this side adjacent? This side has a special name. It has a special name. It's the hypotenuse. Good. And this is the adjacent. Yes? Review for everyone? Okay. Do you remember this? SOHCAHTOA? All right. Does anybody use SOHCAHTOA when you're doing sine, cosine, tangent? All right. Not a formula. This isn't a formula, but it's just a little trick to help us remember what goes where. Okay, so I'm going to write down sine of theta, bless you, cosine of theta, and tan of theta. In words. In words, this is for sine, the C is for cosine, the T is for tangent. O stands for what? Opposite. Old. Some old hippie came a hopping through our apartment. I like it. Who came up with it?
Mr. Bringetto said it in freshman year.
All right, I like it, Mr. Bringetto. So some old hippie came a hopping through our apartment. Okay. So instead of old, which it can be, it stands for what? Opposite over hypotenuse. And cosine, A stands for what? Adjacent over, and still the hypotenuse. And TOA, the tangent, stands for what?
Opposite over adjacent.
Opposite over adjacent. Okay. Now these next 3 are 3 that the class that they did not know. Okay, I'm going to give you the abbreviations and I'll tell you what they stand for. CSC theta, SEC theta, and COT theta. Yes, you've seen them.
Well, I know.
Okay, you know them. Anyone from Math 3? Did you guys do this last year?
We did
I
it
think
last
I
year.
remember like what it represents, but I don't remember exactly what they're called.
Okay, but you've seen it before.
Yeah.
Anyone else in Math 3? Seen and not seen? No? Maybe?
I saw them in Math 2 honors.
Okay, then that makes sense. All right, what do they stand for?
Cosecant, secant, and cotangent.
Good job. He said cosecant, secant, and cotangent. Okay, now what these are the reciprocal functions of sine. This is the reciprocal function of cosine, and this is the reciprocal function of tangent. What does reciprocal mean? To do what to your fraction? To flip your fraction? Okay, I'm glad you said that. The inverse and reciprocals are different things. Okay, and I say that because we will eventually deal with inverse functions. Inverse, like division and multiplication, are inverses of each other. Addition and subtraction, inverses of each other. Sine and cosecant, reciprocals of each other. So make sure you know how to use the words reciprocal versus inverse. I do want to talk about their names really quick. Notice sine and then cosine just pretty much puts co in front of this word up here. Do you see that? Sine and then cosine. This is secant and this one is what? Cosecant, which pretty much just puts co in front of secant, and tangent and then cotangent. Sine, cosine, secant, cosecant, tangent, cotangent. The reason I point that out is because there is a reason these are named the way they are. They are called co-functions. That's why you hear the cosine, cosecant, cotangent. We will not get to co-functions for a few more days, But for now, just keep it in mind. When we get there, you know what it stands for. Okay, for now, reciprocal functions. So what's the reciprocal of opposite over hypotenuse? What would I have? Hypotenuse over opposite. Secant's the reciprocal of cosine, so that would be hypotenuse over adjacent. And cotangent reciprocal would be adjacent over opposite. Okay. I can give you a tool on how to remember which one's which. Do you guys like that? Because there is no SOHCAHTOA for this one here.
Unless you go post hoc out.
Okay. I can't even try to mimic that. So here's how I remembered it when I was taught this many, many moons ago. Sine, cosecant, cosine, secant. Tangent, cotangent. These two just match up because tangent and cotangent, it makes sense. The way I match these up is with the letters S should not match with S and C should not match with C. Does that make sense? So if I give you sine and I'm asking you what's its reciprocal, cosecant or secant, you wouldn't choose the S, so you would pick cosecant. Does that make sense? If I gave you the cosine and I asked you what's its reciprocal, secant or cosecant, secant, because you don't want to pick the C. So C does not go with C and S does not go with S. Do you see that? CS or SC, CS. All right, questions? All right, so you do want to make sure you do spend some time. You have these mastered. You've been doing those since, what, Math 2? But these here, some of you have seen, some of you have not. You want to make sure you make an effort to get those down. Okay, find the 6 trig, and these are the 6 trig functions of theta. And that's number 1. Find the 6 trig functions of theta. Okay, I'm going to give you a picture of a right triangle. And in this right triangle, I'm going to draw theta in this corner. And since you're drawing it with me, I'd suggest you put it in the same place. Right triangle, theta. I'm going to call this leg 18, this leg 12. And am I missing a side? What side did I not give you? The hypotenuse. Do you have enough information to find the hypotenuse? Yes. Can you tell me the formula?
A squared plus B squared equals C squared.
Perfect. A squared plus B squared equals C squared. Where C is always the hypotenuse. Good job. All right. So go ahead, and these are some big numbers. So what are we going to have? 12 squared plus what?
18 squared.
12 squared plus 18 squared equals C squared. 144 plus, anybody have 18 squared memorized? Yeah?
324.
Okay, 324. We add them together. C squared equals 468. And then I do ask that when you square root, you don't do decimals, radical form. So yes, I know this one's not nice, but I will give you the first set of numbers. It's 9 and 52. Go from there. 52 is even at the very least. You can divide by 2. 52 is even at the very least. You can divide by 2. Do you guys remember how to break this down? Anybody break 52? 2 and?
I got 4 and 13.
Or you used 4 and 13? Okay. And if you used 4, then I would have left that at 9, but since I already broke it up, I'm just going to break these up. Bless you. So this comes out as a 3, this comes out as a 2, so what's coming out?
6.
So C equals 6. Root, what stays inside? 13. Got it? Do you guys remember how to do that on your own? Yes? All right. So what you're going to do is you're going to find sine of theta as a fraction and reduce cosine of theta as a fraction and reduce, and then tan of theta as a fraction and reduce. I'd like to start you off, sine of theta. If theta is in this corner and sine is opposite over hypotenuse, which side is opposite, the 12 or the 18? The 12 is opposite over which side is the hypotenuse? Okay, now can I reduce the 12 and the 6? 6 goes into both of them, so the numerator becomes what? The numerator 2, and the bottom just root 13? Okay. Now, what did I say about radicals in the denominator?
You can have them there because you already know we're getting lost or not.
Thank you. That's exactly what I said. You can leave them there because I already know you've been tested on this last year, the year before, back since you were in middle school. I'm not going to test you on it anymore. So is it okay if you leave the radical in the denominator?
Yes.
If it bothers you, rationalize. I will not be rationalizing in notes on the quizzes or the test, but if you do, that's perfectly fine. All right. Next one, cosine. Cosine is adjacent over hypotenuse. So according to where theta's at, is adjacent 12 or 18? 18, and the hypotenuse is still 6 over 13. What goes into 18 and 6? 6. So 3 over root 13. All right, I'm going to have you do tangent, and then I'm going to have you do the reciprocals. Cosecant, secant, and cotangent. Michael, can you give me tangent before you reduced it?
12 over 18.
Do you guys agree with him? Opposite over adjacent, and can you tell me, Michael, what you reduced that to? 2 over 3. Okay, when you guys write your reciprocals, would you flip the original or flip the reduced ones? The reduced ones make more sense, right? Why flip the original and then reduce again? So cosecant would be what? Root 13 over 2. Do I have to come back to my triangle, or since I have this set, can I just flip this set? Flip this set. Secant is root 13 over 3. Darren, do you have a question for me?
Sorry.
No? And then cotangent is what? 3 over 2. And I'm sorry, Darren, was that a never mind?
Yeah, no.
Okay. All right. Any questions? Do you agree it's not that bad? Stuff you've been doing since Math 2, except for this new piece here, which is just flipping your original set here. Got it? All right, number 2. What if you had something like this instead? Given cosecant of theta equals 10 over 6, find the 6 trig functions. Find the 6 trigonometric functions. Okay, that's all they're giving you. They're not giving you anything else. Do they give you enough to draw a picture? Like number 1 came with a picture. This one gave us like a fact here, an information, so a piece of information. Can I use this to draw a triangle? Yes. I will tell you this. It does not matter how you draw your right triangle. You do not have to draw it exactly like I'm drawing mine here. Yours can be flipped around this way, reflected down this way, upside down, any which way, as long as it's a right triangle. Now, same thing with your theta. You do not have to put theta in that corner. You can put it in the top corner, or if your picture's flipped around, one of the non-90 degree corners. It doesn't matter. If you do your work correctly, you would end up with the same answers as everyone else. Okay, so we need to figure out where the 10 and the 6 go. So can you guys tell me what cosecant is the reciprocal of which trig function?
Sine.
Sine. And sine is the so part, so it's what over what?
Hypotenuse over.
Opposite over hypotenuse. So when you flip that, this will be hypotenuse over opposite. So right here, right now, what can I put on the hypotenuse? 10. Okay. Now, this is where you want to make sure if your triangle looks different from mine, you're matching it up correctly. according to theta, where I have, for my theta, which side is opposite? First or second? Second. Now, if you put theta in this corner, would your opposite still be right here? If your theta was in this corner up here, would this be your opposite?
No.
No, your opposite would be down here. So you want to make sure, however you drew your right triangle, different than mine if you did, that your 6 is opposite your theta. All right, do we have enough to find this missing side? A squared plus b squared equals c squared? A squared plus 6 squared equals 10 squared. That one's pretty easy to do. They're not huge numbers. Probably do that in your head. Okay, do we have answers? What is A?
8.
8. A is 8. Okay, now I will tell you this really quick. I forgot to say it. A squared equals 64. When you square root both sides, you don't do plus or minus because you're dealing with the side length of a triangle. Got it? Now I will tell you this. In just the very next problem, we will have negative side lengths. But when you're drawing a triangle like this, just your own triangle, it's not in a quadrant, your sides will be positive. But when you're drawing triangles like this that are in different quadrants, can you see that? Your side lengths will be negative. So that does happen, just to let you know. All right. Okay, I'm going to have you guys do it. Just make sure you reduce sine theta, cosine theta, tan theta, and then your reciprocals. Go ahead and fill them all in. Right here?
Yeah.
Can anybody tell me, well, can you give me the answer for sine of theta? Sine of theta would be what over what?
Opposite.
So 6 over 10. I only have 2 because I know 6 over 10 can reduce. What does it reduce to?
3 over 5.
3 over 5. That's the only reason.
So do you always reduce?
Always reduce.
Okay.
Just
So, like,
make, go
the
ahead.
reason why they didn't reduce like in the statement is because it wouldn't have been the same.
Right. Yeah. Okay. Anyone have cosine, the original cosine before you reduced?
8 over 10.
And original tangent before you reduced?
6 over
Okay, so 8 over 10 reduced to what? 4 over
8.
5, and then this one is?
3 over 4.
And then you flipped them all over here, yes? 5/3, 5/4, and 4/3. Any questions? None? Now, if the test was only on these type of problems, you guys would do well?
Yes.
Yes, okay.
Or unfortunately gets lost.
All right, determine the exact values of the 6 trig functions for theta. Okay. I'm going to give you a drawing on this one. And I'm going to plot a point at -8, 15. -8, -15, sorry. I'm just approximating, but do you agree -8, -15 would be in quadrant 3? Yeah. All right. Now, it's going to be like this, and you will have this line here. Do you guys remember what this guy is called? If I'm here, this is my starting point, and I come around here, this is called the something side, and it starts with a T. Terminal side. Good job. Your terminal side. Got it? All right. Now, here is what you are going to do every single time. You have a terminal side, a point the line coming out from your origin, you were going to make a right triangle. Now I just need you listening first. Do you agree if I did this, that would be a right triangle? Yes. So, well, which right triangle do I make? Because I could also go like this, and this would be a right triangle. Do you agree? And does it matter? It does. You always make your right triangle up or down to your x-axis. You never connect to your y. I see them on the test every year. Kids connect it this way, and it should just feel weird. It should look weird. You never draw your right triangles to your y-axis. So you'll always go to your terminal side, go to your end point, and you're going to go up or down. For example, if my point was up over here, which way would I go? Down. Do you see that? It just depends on where your point is, but you will never go right or left to your y-axis. Questions? None? Okay. The next thing you should know is that theta is always in the corner by your origin. So first off, do you see my right triangle in here?
Yes.
Theta will always be in that corner by the origin, always, every single time. Okay? Our reference angle, remember we talked about reference angle when we first did this, the 3-1? That would be considered your reference angle. All right, now I need to label the sides. What's the length here, or what side would I put here, and what side would I put here? This would be negative 8, because that's left on the x-axis, and this would be negative 15. So these are the ones where I said you'd have negative sides. And it just works out that way. Now it looks funky, like, wait, negative side of a triangle. When you're in different quadrants, yes. But your hypotenuse or your radius, depending on how you're thinking, if you have a circle around here, this will always be positive. So know that. Your hypotenuse is always positive every single time. Okay, do you have enough to figure out your hypotenuse?
Yes.
Yes, you do. Negative 8 squared plus negative 15 squared equals c squared. 64 plus what?
225.
225, and I'll let you guys finish that. Anybody have it? A question on the test?
289.
I'm sorry, what did you get?
17.
C equals 17? Like I didn't give you enough room on there, is that what it is?
Yeah.
Okay. Just make sure you put your name on it and you catch it.
All right, thank you.
All right. Is 17 my final answer?
Yes.
Am I done with the problem?
Not with the problem, but you know how much C equals.
No, we know how much C equals. Do we now have enough information to find the 6 trig functions?
Yes.
Okay, sine theta, cosine theta, and tan theta. I'm going to have you guys go ahead and do that now, and it's reciprocal. Oh, can you guys tell me right now without looking back in your notes what the reciprocal of sine is?
The C1.
The C1, good job. And what about
C-sec or whatever.
the cosine? Which one?
The S.
The S1, and then tangent is cotangent. Okay, so the C1 is
Isn't it CSC?
CSC for cosecant, and then
SEC.
SEC for secant.
SCE. SEC, right?
SEC. All right. COT.
Okay,
that's
I've been
not
spelling it as a U.
Oh, I'm sorry. I'm actually. Okay, so go ahead and do those. Do these reduce?
No.
And is your tangent positive or negative? Anybody?
Positive.
Why did your tangent come out to be positive?
Because it's 2 negatives divided by.
Good. Dividing 2 negatives. All right. Do we have answers? Okay. Is this what you guys came up with? Yes? Okay. Questions? Okie dokie. This next one stumbles students every year on the test, but I think, because you guys have a little more experience with it in Math 3, maybe not, bless you. Test question that kids get stuck on every year. The point is on the terminal side. We just went over what terminal side is. Do you guys remember? That's this guy right here. The point is on the terminal side of an angle in standard position. Period.
How many more notes do we have?
This is it. Find the 6 trig functions. Of the angle. And I'm going to give you the ordered pair is -3, 4. -3, 4. Okay. And then they give you this, and then kids, I'm not sure, they just do some wonky things. Any suggestions on what we should do, where we should start? Plot the point, okay. 1, 2, -3, 1, 2, 3, +4. Okay. So, on the last one, number 3, the point and the terminal side was drawn for us. Was it drawn for us in this case? No, and I think that's maybe where kids get fumbled up. So here's my point. Now, when I draw my terminal side, it always goes to the
X.
You're a step ahead of me. You are correct. We're going to go to the X, but the terminal side first always goes to the origin. Do you agree? Now, I'm not going to put an arrow here, but would it matter how I got there if I went in the positive direction or the negative direction? Would that really matter? No, because I'm going to draw my triangle the same way. Now, he told us when I drop or go up, I'm going to touch the y-axis or the x-axis. X. I never go over, and that's one of the big mistakes kids make. They always go over this way, and again, that should feel funny. It should look funny. Okay, do we have enough to label some sides?
Yeah.
What should go right here? -3. And what is my other leg right here? +4. And do you have enough to find the hypotenuse? Yes, remember your hypotenuse is positive. Go ahead and fill it in. Is it 5? Okay. Now I'm going to have you go ahead and find your sine, cosine, and tangent. And none of these reduce, but then go through and find the reciprocals as well. Yes?
So, with theta, it's always the origin, right?
Thank you. And I didn't put that in there, and I should have. Thank you for pointing that out. Theta is always here, and I should have put that in the picture. Theta, so if you didn't do it, like I didn't do it, please add it in there now. Theta is always the angle that's in the origin, the corner at the origin. All right, what's sine of theta? 4/5. Cosine? -3/5. And tangent? -4/3. It's 4 over -3, but is it okay if I just move the negative to the top? Yeah. All right, so in this, if you look back over here, number 3, in number 3, sine, actually everything was negative except for tangent and cotangent. Do you see that? Those were the only 2 positive. Right now, which one is the only one that's positive? Sine. So over here, which one's going to be the only one that's positive? Cosecant. All right, so we have 5/4, -5/3, and -3/4. Got it? Can anybody tell me why this one has a negative tangent and the last one had a positive tangent? Yes.
The last one had two positives cancelled out.
This one here had the two negatives that canceled out. It's okay. So two negatives that canceled out, and this one had one positive and one negative that did not cancel out. Do you guys agree? All right. Any questions?